What I've done is this first link from today. It's got yesterday's code complete. If you're having issues opening yours, or you're not sure if yours worked or anything like that, I would just recommend everybody uses that the code I posted as yesterday's complete, because I know it works. So that and then it has starter code for today. So whether you got yours working or not yesterday, I would just highly recommend you use the link here. If you want to use your code from yesterday, you can. You would just copy and paste from where it says starting at day 2. If you're pretty sure yours works and you want to test it. However, I am just going to go ahead and copy and paste all of this stuff into a new processing sketch here, just because I know it works. So I would highly recommend you do the same. What you should see is all the stuff from day 1 is complete. Then there's a few new methods from day 2. Again, if you want to use your code that you wrote yourself, you're more than welcome to just kind of start copying. It looks like from line 94 down to the end. You're more than welcome to do that. Spencer, are you able to figure out where processing is on that computer today? Okay, cool. Another one. All right, anybody having issues finding processing or anything like that? Okay. So I've got pasted into processing this code. I just wanted to talk very briefly about count neighbors and my solution before we get into finishing Conway's Game of Life. For the count neighbors method, I just there's probably a very elegant way to write this unlike I have here. Maybe using nested ifs or for loops or something like that. However, there's a lot of different edge conditions you kind of have to test. You have to see when you're checking the row above you that there is a row above you. When you're checking the row below you, you have to make sure there is a row below you. When you check the column to the left, you have to make sure there is a column to the left. When you check the column to the right, you have to make sure there's a column to the right and you're not going to go out of bounds. So I think you probably could be very elegant with nested if statements and stuff like that. I just literally wrote 8 if statements and I used my knowledge of short circuiting to write them. So first of all, we probably figured out this is how you access the guy that's above you and to the left, and seeing if it's occupied or not. Technically, this equals true is redundant. I don't need it because it's a Boolean array anyway. But then I have to check that there is a spot above me and to the left. And so r minus 1 greater than or equals 0 is only true if there is a row above me. C minus 1 is greater than or equals 0 is only true if there's a column to the left of me. If either one of those is false, what do we know about short-circuiting and ands? It's never going to get to check if the guy above me and to the left is occupied or not. If one of those two things is false, it'll automatically kick me out of out of that and, because Java knows when one part of an and is false, the entire thing is false. And so I just kind of used my knowledge of short-circuiting for each one of these if statements. I did the same thing for checking the guys that are in the same row to me and to the left and to the right. I just had to check the column numbers. And then I kind of did the same thing, except when I get to r plus 1, the row below me, I only know I'm going out of bounds if it's greater than. I use the grid.length. Some of you might have used 50, which is fine. I'm just thinking, what if at some later date I want to make the Conway's Game of Life bigger or smaller? That's why I use grid.length instead of 50. Does that make sense? Okay. So, I guarantee there's probably a more elegant way to write count neighbors. I thought this was going to be about the same number of if statements anyway. Yes, Daniel? Could I use width and height instead of grid.length? I think the issue there is width and height refer to the width and height of the window instead of the width and the height of my 2D array, which are, I think we have to think of this in two different ways. There's the physical way that our 2D array is being stored inside of memory, and then there's also the 2D array that we actually see on the screen. And I think they correspond to each other, but they're not exactly one-to-one. Like the element at 3535 is not located at 3535 on the screen. Does that kind of make sense? Okay. So that's why I use this. I suppose you could have done something like that and multiplied by the box width to do something like that. Okay. Moving on to actually drawing the grid and getting the game working. If you scroll down to where it says day 2, I've got a method called draw grid. We are going to finish the draw grid method together here. It says basically draw grid is the one that's going to draw all the boxes on the screen, if that makes sense. Today we're going to be looking at using nested for loops a little bit. I know we haven't read about them just yet, but I thought I could slowly introduce you to them using Conway's Game of Life. Just like we said yesterday, you use one for loop to traverse a one-dimensional array. You're going to use nested for loops to traverse a two-dimensional array. So for draw grid, part A says loop over all the row indices. I usually like to write this for loop. Since I'm looping over the row indices, I'll usually use R as my counting variable. R for row, if that makes sense. If I want to count up to the last row index, how can I figure out the length of the number of rows? Grid.length will give me the number of rows, right? And I'll count by ones there. Left brace, enter, enter, right brace, of course. Never a doubt in my mind. Then it says make a nested loop inside that loops over all the column indices. So I've hit left brace, enter, enter, right brace. Now I'm inside of this loop. And I'll do the same thing basically with my column indices, except how do I find the number of columns? We can do, since it's a rectangular array, I can absolutely do grid sub 0.length. Now, I know ragged arrays were inside of your reading a little bit. Here's why I don't talk a ton about ragged arrays. If this were a ragged array instead of a rectangular array, here's the one change you would need to make. Just changing that 0 to grid sub R will find the length of each individual row, but since this is rectangular, I can just do grid sub 0.length. In my opinion, if you always do grid sub R.length, you'll never be wrong. That'll work for rectangular and ragged arrays, but this is just fine for rectangular arrays for right now, so I'm going to leave it. I know that this is going to be a rectangular array, at least for now. All right. So part A, loop over all the row indices, yes. Part B, make a nested loop inside that loops over all the column indices, yes. And notice I've hit left brace, enter, enter, right brace, of course. Of course. I couldn't go home if I didn't do that. Letter C says, if the grid is occupied, if the element at that spot is occupied, change the fill color to yellow. So I'm going to say something like this. To check if something's occupied in my two-dimensional Boolean array called grid, it's true. So I'm going to say if grid sub R will be the row index, sub C will be the column index. I use two subscripts for a two-dimensional array, and I'm just going to write equals equals true. I know you understand that that's a little redundant because it's an array of Booleans anyways, but I'm just going to leave it there. I think it makes things more readable. It says if the grid is occupied, change the fill color to yellow. I just mentioned this briefly yesterday. There is a variable that contains the color yellow. So down here, I'm just going to say change the fill color to yellow. And yellow is just a variable that I've created up at the top that contains a color that I thought looked yellow. That's all. It's not like it's built into processing. I just declared and initialized it up at the top. It says otherwise, so part C is done, otherwise change the fill color to gray, else fill gray. And since that's all I want to do there, I don't necessarily need the curly braces since I only want to do that one line if it's occupied, or otherwise if it's not occupied, make it gray. So part D is done. And then regardless of the color, I want to draw the rectangle, and I've actually given you the code there to draw the rectangle. Essentially, you can just take this line up here and copy it and paste it in. I'm going to draw the rectangle regardless of if it is occupied or not. It'll just be yellow if it's occupied, gray if it's not occupied. If I take the row number and multiply by the box height, it'll draw the box in the right spot in the grid. If I take the column number and multiply it by the box width, it'll draw the box at the right spot in the grid. And then remember, for rectangles, it goes x, y, then width and height. Well, the width is the box width, the height is the box height. So now, I think at this point, we're done with draw grid, but you won't yet see, oh. Just kidding. I guess it starts coloring it in now for you. And it should be, if you click on a cell that's already gray, it should yellow it out. Is that true? Yeah. Now, it's a little tricky with processing because, remember, processing, the draw function is going 60 times a second, so you have to kind of be quick with your clicks. Otherwise, if you hold it for too long, it kind of flashes on and off and all that stuff. Was yours drawing drawing the boxes okay? Anybody having an issue? Yeah, Cooper? What's it doing? It's doing nothing. Did you use your code from yesterday? So if you use your code from yesterday, I would scroll up. I think I have draw grid commented out. Yeah, just comment it back. Just you can right click on it and comment it back. Get rid of that. Try that. Did you hear what I just said to? Try running it one more time. Yeah. So you click on any element, it's getting out of bounds. So that would tell me probably something in count paper might be off with that. Okay. I would comment back in progress. I just got commented out yesterday because we hadn't written it. Really quick, for those of you that are using your code from yesterday, I believe I had commented out the call to draw a grid. So if you're using your code from yesterday, you might have to look up at draw. I had commented out draw grid because we didn't write it yesterday. So now if you're using your code from yesterday, you probably have to comment draw grid back in. It's up inside a setup, or up inside draw up at the data. When did it go -2? Can you click on here again and run it one more time? So when you click on any cell, it does that? I bet it goes, I bet if you click and drag all the way to the left, then it goes out of bounds. So I think it's just, you just want to make sure you're clicking inside of the. Oh, C is less than on line 106. Right, yeah. So that's how, can I bring that up for everybody? That's a good point. Ammon asked a really good question. The way that it knows what box you're clicking in, this is a method I had written yesterday and you had in your code there called change element. Essentially, I call this change element method whenever somebody clicks, just check the classroom, gentlemen. Okay. Whenever somebody clicks, I call this change element method. Essentially, it figures out where the mouse click was by using the variables mouse x and mouse y. And if you take the mouse x and divide it by the box width, and you take the mouse y and divide it by a box height, it'll give you the location inside of the two-dimensional array where you clicked. And I just basically said, if you look at lines like, I don't know what they are, 33 through 35, it just basically says switch that grid. Make it its opposite. So if it was true, make it false. If it's false, make it true. So it's this change element method that kind of does that magic in changing, well, figuring out what box you clicked in and then also switching that box. You do have to be a little bit careful when you're doing your clicking. If you click and drag and then you hold it as you go off the screen, it might give you an array index out of bounds because it's still reading the mouse position as you've clicked. And obviously if you go off the screen, you're going to get a negative. So just be really careful. I think the same thing happens if you go right, go up, go down. Basically, it's just because change element is trying to change an element that doesn't exist inside the array. If you ever get an error like this inside of processing, I just recommend clicking on the window and just pressing play again, all that stuff. Okay, questions there? I think the last part is actually having Conway's Game of Life play, because right now you can fill it up, and what's supposed to happen is when you click enter, it's supposed to update. But right now, the update method is not doing anything. So I think we got to go down to day 2, and there's one more method here called update. Now, the way Conway's Game of Life works is you need to update the entire state of the array at the same time. So I can't just start in the top left corner and update that cell, and then update the next cell, and update the next cell, and update the next cell, because then those new cell values are interfering with the old ones as I go through my loop. So essentially, I need to make a new two-dimensional array that's going to hold the next value, the next state of the array, and then I copy it all over at the same time, because everything has to change all at the same time instead of one cell changing at a time as I go through the loop. I know that can be a little confusing. Just think of it like this. We pretend we're all elements in a two-dimensional array. Time moves at the same speed for all of us. Clay doesn't get 1 second ahead, and then Dana, and then Spencer, and then Ben, and then Nikki, and then Jenny. We all move 1 second ahead in time all at the same time. So it's kind of the same thing with Conway's Game of Life. That's why we kind of need this temporary array to do our job. So inside of update, it says make a new Boolean 2D array that holds the same amount of elements as grid. So I'm going to call this, first of all, the way that we make a new 2D array of Booleans, I'm going to say Boolean. That indicates it's just a single Boolean variable. To indicate it's a two-dimensional array, I'm going to do square bracket, square bracket. That indicates it's a two-dimensional Boolean array. I'm just going to call it new grid. And to make it the same size, same number of elements as grid, I'll say new Boolean. How can I say it has the same number of rows as grid? How do I find the number of rows in grid? That'll give me columns. Not a function, darn. How about grid.length? Oh, that'll give me the number of rows, okay. And if I do grid sub 0.length, that'll give me the number of columns. So part A, make a new Boolean 2D array that holds the same amount of elements as grid. This is an array that is the same size. All right. Part B, it says loop over all the elements in grid using a nested loop. So I'm kind of going to use that same nested loop from the previous part. We always do rows first, followed by columns. So I'm going to say for int r equals 0, r is less than grid.length. That's the number of rows in grid. Left brace, enter, enter, right brace. Inside of that, I need to figure out the number of columns in each row. So I can do something like int c equals 0. C is less. Now, this loop is related to C, so I want to say C is less than. And let's pretend for a second maybe it's a ragged array. Instead of writing grid sub 0, how about I write grid sub r.length? That'll say the number of elements in each row. Except I know that that loop will work no matter if it's a rectangular array or a ragged array. Part C says, call count neighbors to determine how many neighbors the location RC has. So if you remember count neighbors from the other day, count neighbors expects only an integer R representing the row and an integer C representing the column. Great news is I've named these variables R and C. So maybe I'll do something like this. Int num neighbors equals, and I'll call count neighbors and pass it the variables R and C, or whatever the values of R and C are. So this will say count how many of the spots in my perimeter are occupied, essentially. And instead of writing in that whole method here, we've already written a method. And so I'm just calling it, and look how simple that is. The number of neighbors is, well, count neighbors, you go take care of figuring it out. And then it says, D, use the Conway's Game of Life rules to set the value for the corresponding, position only has one S, so sorry everybody, of the new grid. I have the Conway's Game of Life rules in front of me, so I'll repeat them. It says, if the number of neighbors is 0 or 1, you die as if by solitude. If the number of neighbors is 4 or more, you die as if by overpopulation. So I'm going to say something like, if the number of neighbors is less than or equal to 1, that means I die of solitude, or the number of neighbors, be careful that you're spelling neighbors correctly, which I'm currently not doing, is greater than or equal to 4, overpopulation, that means the new grid at RC is false. That means I'm dead. Oh, wait a minute. Hold up. That only applies, though, if the grid is currently populated. I kind of goofed this here. I'm worried if I write this in a nested for loop, it won't work. Okay, hold on. I goofed up. This only applies if it's occupied. You can control X that if you want to. Cut it, or copy it, whatever. We need to first double check that the grid is occupied. Sorry about that. These rules only apply when the grid is occupied first. So I'm going to say if the grid is occupied, then I'll use that rule. Now, if you're wondering, why am I using grid and new grid? Well, grid contains the current state of Conway's Game of Life. New grid is going to contain kind of the next step. Do you remember when we looked at Conway's Game of Life for the first time and we were clicking the next button? New grid contains basically what's going to be in the grid when you click next, the next step. So we want to say grid is the current state of Conway's Game of Life. New grid is going to be the next state of Conway's Game of Life. So I basically said if the spot is occupied, check the number of neighbors, and if the number of neighbors is less than or equal to 1 or greater than or equal to 0, basically kill them. Sorry. Otherwise, if the number of neighbors is 2 or 3, they get to live. So I'll say else if num neighbors is 2 or, my goodness, or 3, then new grid sub R sub C is true. They get to live. The last rule in Conway's Game of Life is that if the element is currently unpopulated, but it has 3 neighbors, then it lives. It gets spawned into life. Almost like there's some people around, well, this is a great place to live. Somebody's going to move there. So I'm going to say after this if statement, I'll say something like else, meaning the place is unoccupied. Left brace, enter, right brace. Then I'll say something like else if num neighbors, I can't spell the word no matter what, equals 3, then new grid sub R sub C is true. The place that was currently unpopulated becomes populated because they go, wow, what a great place to live. There's 3 neighbors, that's the perfect number of neighbors for me. I believe the last step says, at the end of the method, point grid at the new grid or do a deep copy. I basically say after I've figured out the state of the next frame, then right at the end of the method, I'm going to say grid is equal to new grid. Now, if I don't do that, all the work I've done with new grid goes away. New grid is just temporary to this method, but if I point grid at new grid, it'll save where I'm at there. And in this case, it's okay to not do a deep copy because new grid, like I said, is just going to go away at the end of this method due to the way it's declared. That way, grid is the only thing referring to that new grid. Now, I believe in my heart of hearts, if you've got this code written down, as I have, for those of you that copied my code from today, you should be able to just click around here and then hit enter, and it should start to update. For those of you that used your code from yesterday, I believe maybe the only thing you have to do is uncomment out update inside of draw there. But for the rest of you that copied my code from yesterday, today, you should just be able to run it. And you can hopefully check some of the patterns. I believe this one pattern is called a glider. You can do like 10 across as well. And basically you have to hit enter to start the simulation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can do that. There's this interesting pattern that looks something like this here, like two sideways T's kind of pointing at each other. And then when you hit enter, I believe it should start to evaluate Conway's Game of Life. And then if you want to stop it and clear it and start over, I believe you could hit Control and it should clear the screen and allow you to put in new Conway's Game of Life and the elements there. Oh, it made a glider going the other way. That's interesting. I love Conway's Game of Life because it's a very, very simple set of rules. You folks have spent, 3 days on two-dimensional arrays, 2.5 days, and it's a simple set of rules, but out of that simple set of rules, you can have some very complex, emerging patterns, and I think it's very interesting. Just a quick note, I believe the real Conway's Game of Life uses like one extra fake row or column on each side just as kind of like a buffer zone. So this is very similar to what Conway's Game of Life is, except there's a little bit of difference when stuff gets to the edge. But otherwise, yeah, that's Conway's Game of Life. Then we've written it in a way where it should be very simple to change the number of elements. If you wanted to instead do 100 by 100 instead of 50 by 50, if you wanted to change the size of the screen, it should be very easy to do that as well. So. Good activity, bad activity? Good activity? Okay. All right. I know I've been, I don't want to say I've been loading you folks up with work. There's been a little bit of work here and there. How long did last night's assignment take? Okay, not super duper long. Tonight, I just want you to formalize what we talked about a little bit with nested loops. It says here, take Cornell notes on the APCS Awesome link on nested loops for 2D arrays. Day 1 only, so it's much shorter than what we took notes on the other day. It just talks about how to write your nested for loops for a 2-dimensional array. And I'm only making you guys do the day 1 part. You don't have to do the enhanced for loop. If you want note sheets, right by where Cooper was just standing in that purple bin by the tissues over there, there are purple bin. By the purple bin, there's Cornell note sheets. If you would like one of those, unless you're using your own notebook or the back of another one or something like that, you may grab one. Again, they're by the purple bin over by where the tissues are. You can see where John's standing. That's your homework. It's only that first couple sections. Just follow the link. Second thing, if you have not yet registered on the College Board, I posted the link the other day. If you have not yet registered on the College Board, they are going to send out reminder emails to people that are registered that you can start paying for the exams, because we're a Try-2 exam. We didn't have to pay yet. Or a Try-2 class, you didn't have to pay yet. But you need to make sure you get registered on the AP Classroom. If you forgot how to do it or you missed the day, January 13th's post contains information on how to register on the College Board's website. You need to have that done this weekend. Preferably, it's already been done already, or you're getting it done today. Again, the only other homework is taking notes on this very short section. Questions?
Are there any repercussions if we pay them during Try-1?
No, you should be fine if you as long as you're still registered from Try-1, then you should be okay.
All right.
Yep. All right. Have a great long weekend.